Hello guys and welcome back to a new video. Today's video is going to be on trigonometric substitution, or trig sub. So first I'm going to go over some substitutions, formulas, with A being some number that is not a variable or constant. So our first formula, the root of a squared minus x squared. Okay, so if you see this in your equation or integral, then you just substitute x to a sine theta. Okay? And our next one is going to be the root of a squared plus x squared. And this is the same as x squared plus a squared. So for this, x is going to be equal to a tan theta. Okay, and our last one is going to be the root of x squared minus a squared. So the root of x squared minus a squared. So in this case, x is going to be equal to a secant theta. Okay? So let's start with the first integral question. Okay, what about the integral of the root of 9 minus x squared over x squared? Okay, so the way we're going to do this is, as you noticed, a squared minus x squared is here, with a being 3. So a squared minus x squared is here. Okay? And a squared minus x squared is here. And here, we just have to sub in a sine theta for x. So let's do that. So a, in this case, is going to be 3, as we're basically taking the root of a squared, which is going to give us a, equals the root of 9. Okay? So that means that a equals 3. That's really bad 3. Sorry. A equals 3. Okay? Great. So now let's write in the substitution for x. X equals 3 sine theta. Okay? And you may also notice we have dx here. So we are going to want this in terms of theta, as this term is going to be, this integral is going to be in terms of theta now. So let's change the dx. So we basically just have to take the derivative of x, which is equal to 3 sine theta, and the derivative of a constant, or the derivative of a constant times by a variable is going to be, let's say, it's going to just be that same constant multiplied by the derivative of the variable. So let's go, just say y, okay, for instance, or x, sorry, x equals, let's say, 3 sine theta, because that's what we're doing in this case. So dx equals 3, and then the derivative of sine theta, then d theta. Okay, so we can put this in up here. Okay, so dx is equal to 3 times by, and then the derivative of sine theta is cosine theta. So 3 cosine theta d theta. Great. Okay, at this point we can begin our substitution. So let's do that. Okay, so this is going to equal the integral of the root of 9 minus, okay, x, which is 3 sine theta, and then squared, because that's what x is. X is being squared. And then over 3 sine theta squared. Okay? Great. And then we have to also sub the dx. So dx is 3 cosine theta d theta. Okay? So at this point, this is what we want our integral to look like. So now we can actually go ahead and work out the exponents. So this is equal to the integral of the root of 9 minus, and then with this exponent, we basically just move this exponent to the 3 and then the exponent to the side. Okay? Great. So that means minus 9 sine squared theta. Great. Okay? Over 9 sine squared theta. 3 cosine theta d theta. Perfect. So now we can actually factor out the 9 in the root. Okay, so the integral of the root of, and then we factor out the 9, so we get 9 times by 1, because 9 times 1 is 9, and then minus sine squared theta. Sine squared theta. So this is we take the root of this, then we divide it by 9 sine squared theta. Okay? And then times by 3 cosine theta d theta. Perfect. Now we can actually take the root of the 9 multiplying the 1 minus sine squared theta, so equals the integral of the root of, equals the integral of 3, because that is the root of 9, by the root of 1 minus sine squared theta. Okay? So now you might actually be able to see here that the 1 minus sine squared theta can actually be turned into cosine squared theta. Why is this, you may ask? Well, sine squared theta plus cosine squared theta equals 1. Okay? So that means that cosine squared theta is going to be equal to 1 minus sine squared theta. Okay? Understand? Great. So this is going to equal the integral of 3 root of cosine squared theta, cosine squared theta, is equal to cosine theta. Okay? So 3 times by cosine theta, and then we can feel free to square it, as this part here is multiplying this part. So we'll square that, and then over 9 sine squared theta. Sine squared theta. Then d theta. Okay? So this is going to equal the integral of 9 cosine squared theta over 9 sine squared theta. Okay? So now you might be able to see that there's a 9 on the top and a 9 on the bottom, and they are both multipliers. So we can actually cancel them out. Cancel. Okay? So we are left with the integral of cosine squared theta over sine squared theta. D theta. And now we can actually turn the cosine squared theta over sine squared theta into cotangent squared theta. So let's do that. Equals the integral of cotangent squared theta, d theta. Okay? Understanding? Great. So, cotangent and cosecant behave pretty similarly to tangent and secant. So that means that cotangent squared theta, if it does behave similarly to the tangent squared theta, which it does, it should be equal to cosecant squared theta minus 1, because tangent squared theta, right, plus 1 equals secant squared theta. Okay? So that means that tan squared theta equals secant squared theta minus 1. Okay? But they behave similarly, the tan squared and secant squared, to cosecant squared and cotangent squared. So here we can actually do the integral, right, of cotangent squared theta equals cosecant squared theta minus 1 if they behave the same, which they do. So we can write this as cosecant squared theta minus 1. There we go. D theta. Okay, so now we can actually integrate. Sorry, that cosecant looks really funky. Let me just fix that. Cosecant. Great. So we can actually integrate cosecant squared theta. You may be wondering how. Well, we know that the derivative of cotangent theta is equal to negative cosecant squared theta. Okay? So we can actually that means that the integral of cosecant squared, that means that the derivative, of negative cotangent theta is equal to positive cosecant squared theta, okay? So that means, right, that the integral of cosecant squared theta is negative cotangent theta equals negative cotangent theta, okay? Minus, and then what is the integral of 1d theta? Well, theta. So this is our answer. But But you may notice that it is in terms of theta, which is not our starting variable. Our starting variable, if you actually hadn't realized, what is x. So we are going to need to turn this back into x variables. Okay? So the way we can do this is we can draw a right-angled triangle, because this will enable us to use the Pythagorean theorem, with an angle of theta, and this will help us work out what negative cotangent theta and theta are equal to in terms of x. Okay, so our starting formula was x is equal to 3 sine theta. So let's write that. X equals 3 sine theta. Okay, so that means that x over 3 equals sine theta. So, and if you may remember, sine is actually opposite over hypotenuse. So that means that x is the opposite, x, and 3 is the hypotenuse, 3. So knowing this, we can work out, using the Pythagorean theorem, what the adjacent side is equal to. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared being the hypotenuse. So that means that x squared plus b squared, because that's our unknown, so we want to find b, equals 9, or 3 squared. So that means that 9 minus x squared equals b squared. So now we just take the root of both sides, which is the root of 9 minus x squared equals b. So another cool thing when you're doing trig sub is, if you've done your calculations correctly, you should get the same root as you had at the very start. So here we've got 9 minus x squared, the root of 9 minus x squared, and down here we've got the root of 9 minus x squared. So this is good. So now the root of 9 minus x squared is our adjacent side. Okay, so now we can work out cotangent. Cotangent, alright, is cotangent is cosine divided by sine. Okay, so that means that cotangent equals cosine over sine. Great. So a way we can work this out is equals cosine theta times by 1 over sine theta. So cosine theta, cosine is adjacent over hypotenuse. So we'll write that. The root of 9 minus x squared over hypotenuse 3 over 3, yep, times by the arc sine, because the arc sine is sine to the negative 1, right, of x over 3. So if x over 3, right, is sine is sine to the positive 1, that means that 3 over x is sine to the negative 1, as you're sort of basically switching around, like the bottom making it the top and the top making it the bottom. So over 3x. Nice. So we can see here that these 3's, as one is a denominator and one is a numerator, and they're both being multiplied by each other, they can cancel out. Oopsies. So we are left with the root of 9 minus x squared over x. Okay, so this is equal to cotangent theta. Okay, now we are going to need to find theta. This part can sometimes be a bit harder, but it's pretty simple. So we'll just circle this so that just highlight this so that we remember it for later. So remember earlier how x over 3 equals sine theta? Well, to isolate theta, we just have to take the arc sine of both sides. So that means that sine to the negative 1 of x over 3 equals sine to the negative 1. I'll write it beneath it because it's not enough room. Sine to the negative 1 sine theta. Okay, so this means that theta, okay, because these cancel out, this means that theta is equal to sine to the negative 1 x over 3. Okay, so now we can actually go ahead and put these two into our final answer. So negative root of 9 minus x squared over x, okay, minus sine to the negative 1 x over 3 plus c. So just negative cotangent. Yep. So this should be our answer for this first integral. Okay? So our next question is going to be the integral of, let's say dx over why don't actually okay let's do dx over x squared root of x squared minus 9. Okay, so here in this integral you can see that we have a x squared minus a squared. So let's go back up here. What is x squared minus a squared? X squared minus a squared is x equals a secant theta. Okay, so that means that in this case x equals 3 secant theta. Okay, that means that the derivative dx equals 3, and then the derivative of secant is tan theta secant of theta d theta. Okay, so let us sub these in. Equals the integral of 3 tan theta secant theta secant theta over, I'm not sure if I have enough room, 3 secant theta squared root of 3 secant theta squared minus 9. Okay? So, also, if you want to just give this integral a go by yourself, that's fine. So this is going to equal the integral of 3 tan theta secant theta, right, over 9 secant squared theta, and then the root of 9 secant squared theta minus 9. So if you remember from earlier in the video, we can actually factor out the 9 in 9 secant squared theta minus 9. Also, if you're confused why we're using trig sub, it's actually because some of these square root integrals, they're impossible or almost impossible any other way. Okay? So, trig sub helps to simplify these integrals. And you may think, but why would making it harder, putting in trigonometric expressions, make it easier? Well, if we didn't put in trigonometric expressions, there'd be no other way for us to be able to integrate it. Or it would be extremely difficult and require many, many steps and weird formulas, which not everybody knows. So let's do this. The integral of 3 tan theta secant theta, and then over 9 secant squared theta, right? And then remember, so I probably won't do so we factor out the 9, right? So 3, and then times by the root of secant squared minus 1. And remember how earlier we talked about secant squared minus 1 just being tangent squared? Yeah. So we can actually just do this. So 3 and then, so 3 and then the root of tan squared theta, which is just tan theta. Tan theta d theta. Nice. So we're almost finished this integral actually. We now just have to, if you see, we can cancel the 3, cancel the tan, and cancel 1 secant. Okay? So we're left with 1 over 9 secant theta d theta. Okay, so now we're getting towards the back end of this integral. So this is how we're going to do it. Secant theta is actually 1 over cosine theta. Okay? Great. So that means that this is going to equal the integral of 1 over 9 times by 1 over cosine theta. Okay? Got it? Good. Okay. E theta. So this is going to equal the integral of 1 over 9 over cosine theta d theta. Great. So now we've actually almost finished this integral. Okay. So now we are going to do, sorry. No, that's not right. Sorry, my fault. So now, right, 1 over 9, right? So that's just going to be 1 over 9 times by, and then 1 over second, which is just cosine. So, wait. Just wait a second. Okay, so equals 9 over cosine theta, okay? D theta. So here, right, we actually just flip this because it's basically the arc of it. So cosine theta over 9 d theta, right? And this is equal to 1 over 9 times by the integral of cosine theta d theta. So what is the integral of cosine theta d theta? Okay, so the derivative of sine theta is cosine theta, so that means sine theta. Sine theta d theta. Oh, sorry, no. What? No. Plus c. Now we have to find sine. So we can do the right angle triangle again. And we do x equals 3 secant theta. Okay? Because that was our sub for x in the beginning. So x over 3 then is equal to 1 over cosine theta. So that means that 3 over x equals cosine theta. And if you remember, cosine is adjacent, or 3, over hypotenuse, or x. Okay? And then that means, what the heck, that is not a 3. So that means that the opposite side should be, right, if x is the hypotenuse, 9 plus b squared equals x squared. So that means that x squared minus 9, the root of this, is going to be equal to b. Okay? So the root of x squared minus 9. And that was our beginning integral, okay? So we can actually, so this is going to equal 1 over 9, and then sine theta is just opposite over hypotenuse. So opposite is the root of x squared minus 9 over the hypotenuse, which is x, and then plus c. Okay? So that is our answer for this integral. Thank you for watching this video on trigonometric substitution. I hope you learned something new, and I might post another video on this going into more depth in the future, and also providing more trigonometric substitution equations. I'm also sorry that I didn't post for a while. I've been a bit busy, but the main things I want you to remember for this actually is that calculus, this is just a side note, calculus can be really fun, and especially this, I find it's a really nice mental exercise. But the main thing to remember, right, with the main steps that you can go through in your head is basically, so you basically sub, and then you can solve exponents. Then I would factor, and then I would, after factoring, I would try and simplify. But when you do these, you need to have a really good understanding of trigonometric formulas, like sine squared minus 1, like sine squared, 1 minus sine squared equals cosine squared, and cotangent squared minus 1 equals cosecant squared. Okay? Sorry, no, what? Cotangent squared, okay, no, I don't think that was correct, but anyway, I'm not really thinking straight. Anyway, so I want you guys to succeed, and I hope you learned something new from this. I think it's really fun, and it also looks pretty impressive, but it's really quite easy when you get the gist of it. And the part I really enjoy about it is the right angled triangle part with the angle theta. I think that's a really cool part, like changing the variable from one variable to another. I think that's pretty cool, just using like one formula. So like we can basically get any trigonometric formula on Earth with this little right angled triangle and x equals a and then some trigonometric formula.